Hello, everybody. In this lesson video, we are going to go through lesson 0.05. Oops, I guess we're writing this in green. Solve linear equations. So we've recently just been dealing with expressions. I have numbers, variables, exponents. Equations set two quantities equal to each other. Quantities equal. Oops, I don't know why I made it that big. Equal to each other. So, an example of a very basic equation. 1 plus 1 equals 2. That's an equation because on the left side, we have 1 plus 1, which is 2. And 2 does in fact equal 2. If I put these both on a scale, they would balance each other out. They're equal to each other. Not an example, 1 plus 1 does not equal 3 because we already said that 1 plus 1 is 2 and 2 does not equal 3. 3 is a little bit heavier, so that would tip the scale a little bit more. That's not an equation. So we are not going to be looking at equations as simple as that. Our equations might have some numbers and some variables. So a key part of this, oops, I'm going to do this one. Key, you solve an equation to find unknown variables. And specifically, we want to find the value of unknown variables. So your goal here is really to isolate the variable, which means get the variable all by itself. And I want to know x is equal to what? And the way that we do this by using opposite, or what we call inverse operations. Inverse operations. So what are the inverse operations? Adding and subtracting will undo each other. And multiplication and division. So if you see something being multiplied, you can undo that by dividing. I love that. Okay. Okay. Super, super key. I'm going to say this a lot, especially in class. Like, put a bunch of stars. This is so important. Lots of magic. What you do to one side this is specifically one side of your equals sign, you must do to the other. If I'm trying to solve an equation and I see maybe that I have some division happening on one side, so I think, oh, okay, I'm going to undo that by multiplying, and I only multiply something to one side, I'm changing the equation. I'm changing it significantly. I'm tipping the scale one way. So what you do to one side, you must do to the other because that's just going to keep balance. It's going to keep the equilibrium, if you will. All right, let's do some examples now. So example 1, we are going to solve for x. And the equation we're going to solve is -5 equals x plus 7. So this is an equation with two sides. On the left side, I have -5. On the right, I have x plus 7. And my goal is to figure out what is x. So looking at what is going on with x right now, I notice on the right-hand side, we have x plus 7. So to get rid of that plus 7, I'm going to subtract 7, not just from the right-hand side of the equation, but also from the left. What I do to one side, I have to do to the other. So looking at the left-hand side first, -5 minus 7 is going to give me -12, which is equal to, on the right-hand side, we have the +7 and the -7, so those two cancel each other out because 7 minus 7 is equal to 0. So that just goes away, and we have x. So looking at this, I have -12 equals x, which is really the same thing as x is equal to -12. Now I can always check my answer by substituting our value that we found for x back into the original equation. So our original equation was -5 equals x plus 7, and we said that x is -12. So if I substitute in -12 on the right-hand side, -12 plus 7 gives me -5, which sure is equal to -5. So that is our solution. X is equal to -12. Number 2, we're going to solve for c. C minus 6 is equal to 15. And some of y'all might be able to do this just kind of by looking, and that is totally fine too. Just know that later on, there's going to be some where you can't just kind of see the answer. So I am going to look at what our variable is here, which is c, and I want to figure out what is c equal to. And I see on the left-hand side, I have this c minus 6. I'm going to add 6 to both sides. So that way, the -6 and +6 will cancel, and we'll be left with just c is equal to, on the right-hand side, 15 plus 6 gives me 21. And now I can check my answer. Our original equation was c minus 6 is equal to 15, and we said c is 21. And if I subtract 21 minus 6, that does give me 15. All right, number 3. Let's solve for y. Solve for y. 12y equals 72. So I want to get y all by itself, and I notice that I have this 12 just right in front of it, and I don't see a plus sign, I don't see a minus, it's not a fraction. This is 12 times y. So to get rid of this multiplication, I'm going to divide both sides by 12. And remember, when I have the same number in the numerator and the denominator, those cancel. 12 over 12 is just 1. So I am left with y is equal to 72 divided by 12, which is 6. And then again, we could check if I substitute in 6 for y, 12 times 6 does give me 72. I only have a few more. Let's solve for n. We have n divided by 6, or n over 6 is equal to 8. Remember, fractions just represent division. So I have n divided by 6. To undo that, I can multiply, do the opposite of division, and I'm going to multiply both sides of my equation by 6. So on the left-hand side, I have 6 basically over 1 times n over 6. And looking, I have a 6 in the numerator and the denominator, those cancel. So I really just have n, which is equal to 8 times 6, or 48. And then I can check my work. N we found to be 48 over 6. And 48 divided by 6 is 8. So that is our solution. That equation is true. All right, let's look at two slightly more challenging examples. So let's solve for t. 70 is equal to negative 8t plus 38. Looking at this equation, I want to know what t is. And I kind of see a lot going on with t, right? I have this 8 in front, which remember that's multiplication. So I have negative 8 times t plus 38. When you're solving, you're really just going to undo the order of operations. So we are going to undo PEMDAS. So at the end of PEMDAS is the addition subtraction. That's what we're going to start with. So I'm going to start by tackling this 38 that's being added to negative 8t. And to essentially get rid of this 38 that's positive, I'm going to subtract 38 from both sides. And sometimes I really, if the equations are a little bit more complex, I will draw a dashed line through my equal sign, and that's going to help me keep the left and the right-hand side separate. So I'm subtracting 38 from both sides. 70 minus 38 gives me 32, which is equal to, we didn't do anything with this negative 8t. Oh, that's fun. So I'm just going to bring it down. And then positive 38 and negative 38 will just cancel each other out. So now I have 32 equals negative 8t. And remember, we said this is negative 8 times t. So to undo the multiplication, I will divide both sides by negative 8. Negative 8 over negative 8 will just cancel out. So on the right-hand side, I didn't mean to scroll that much. On the right-hand side, we will have just t is equal to 32 divided by negative 8 is negative 4. And then we can check our work again. I always like to check it. It does not take too long. So our original equation was 70 equals negative 8t, and we said t was negative 4 plus 38. Looking at this equation, we have 70 equals negative 8 times negative 4 is positive 32 plus 38, and 32 plus 38 does give me 70. So this equation is true if negative 4 is equal to t, or t is equal to negative 4. All right, one more, last one. Thank y'all for hanging in there. Solve for h. So we have negative h over 5 minus 27 is equal to negative 21. All right. So looking at this, and I just want to say, if you would like to pause this and try this on your own, if you're feeling confident, that is great. If you're like, I have no idea where to get started because fractions scare me, I don't blame you. Remember that we're really just wanting to undo the order of operations. So undo PEMDAS, beginning with addition and subtraction. So start at the bottom, work your way up. So we have subtraction over here. If I'm looking at what we have on the same side as our variable h, this negative 27's got to go. So I'm going to undo that by adding 27 to both sides. I'm going to divide my equation in half. So on the left-hand side, the negative 27 and positive 27 are just going to cancel. And we now have negative h over 5 is equal to negative 21 plus 27 gives us positive 6. Now, I essentially have division here, and I want to note this is like negative 1 times h. Any negative, oops, I didn't mean to do that. any negative can be applied to the denominator. So if I wanted to change this to positive h over negative 5, I could do that. Just because it's a -1, and the way negatives and multiplication work, I could just flip it. And that kind of helps us out here. So if I rewrite this as h over -5 is equal to 6, then to get rid of this division that's happening, oops, I'm going to multiply both sides by -5. That looks horrible. But I'm going to multiply the left-hand side and the right-hand side by -5. On the left-hand side, the -5 on the outside and the -5 in the denominator just cancel, because this is like -5 in a numerator over 1, and they're being multiplied, so they cancel, leaving us with just h is equal to 6 times -5, which is -30. And then I can check my work. Our original problem was negative on top, and then we got h to be -30. So we have -30 over 5 minus 27 supposedly should equal -21. And let's see if it does. So -30 just turns into positive 30. So I have 30 divided by 5 minus 27 is equal to -21. 30 divided by 5 is 6 minus 27. And 6 minus 27 is -21. So this equation is true. Please let me know what questions you have on this section, and I'll see you in class.